Exercise 6.7 from Calculus SM Yusuf book. We are going to discuss the important questions from the past papers from this exercise. So question number 7 has came two times in the past papers, like in 2017 and 2016, that find the points at which r is equals to 1 plus cos theta has horizontal and vertical tangents. Then from the same exercise 6.7, question number 9, we have to find down in from question number 9 to till 11. I will solve only question number 9. Following that method, you can solve the question number 10 and 11 as well. So in this video, I will only solve question number 11. You have to find down the equations of tangent and normal at the given indicated points. The method will be remain same for 10 and 11 as well. So you just concentrating on question number 9, you can just solve the question number 10 and 11 as well. Question number 12 is show that the normal at any point of the curve is given x and y, is at a constant distance from the origin. So first of all, you have to find down the equation of normal, and then you have to find down the distance of point from a line formula, and then you have to prove it that it is a constant distance from the origin. Then question number 14, show that the pedal equation of the asteroid, pedal equations is r square is equals to a square minus 3p square. And in question number 15, prove that the pedal equation of the curve, this curve is given, it is 9 times r square minus a square is equals to 8p square. Both of them have the same method. Following the same method, you can solve the question number 16 and 17 as well. So I will solve only these highlighted questions in this video. So starting from question number 7, find the points at which r is equals to 1 plus cos of theta has horizontal and vertical tangents. Now we have r is equals to 1 plus cos of theta. We know that x equals, we need the parameter equations basically. Parameter equations, that is x and y. X equals r cos of theta. It means it will be equals to r is 1 plus cos of theta times cos of theta. So x will be equals to cos of theta plus cos square of theta. Now y will be equals to r sine of theta. These are the parametric equations basically. R sine of theta, that will be r is 1 plus cos of theta times the sine of theta. So it will be sine of theta plus sine of theta cos of theta. Now we need to find out basically dy by dx. For finding the dy by dx, we need dx. We know that dy by dx can be written as dy by d theta times d theta by dx. So for that purpose, we need from here dy by d theta, and from here we need dx by d theta. So first of all, I am finding dx by d theta from this equation. So mark it as equation number 1. Dx by d theta will be from this equation, that is this one, cos of theta plus cos square of theta. Find down its derivative, it will be minus sine of theta, and here minus 2 sine of theta cos of theta. So we need in equation number 1 d theta by dx, so take its reciprocal. We will get here from d theta by dx equals minus 1 over sine of theta plus 2 sine of theta cos of theta. I simply took the reciprocal and took the negative sign as common. Now I need dy by d theta, that I can find from this equation, y is equals to sine of theta plus sine theta cos of theta. So dy by d theta will be equals to cos of theta plus cos square of theta minus sine square of theta. Now what we have to find out? We have to find out the horizontal and the vertical tangents. So first of all, for horizontal tangent, we know that for horizontal tangents, dy by d theta will be equals to 0, and dx by d theta cannot be equals to 0. For horizontal tangent, we know that dy by d theta can be equals to 0 and dx by d theta will not be equals to 0. So for that purpose, this thing will be dy by d theta over d theta by dx. So from there, if we use the values from here, d theta by dx and dy by d theta in equation number 1, we will get the value of dy by dx. Now for horizontal tangents, dy by d theta is equals to 0 and dx by d theta cannot be equals to 0. Now using this one, dy by d theta, make it equals to 0, we will get here cos of theta plus cos square of theta and then minus sine square of theta will be equals to 0. Cos of theta, now here we can convert it into completely cos of theta. Put the value of sine square of theta here. That is 1 minus cos square of theta is equals to 0. Open the bracket and after solving, we will get 2 cos square of theta plus cos of theta minus 1 is equals to 0. Now using the quadratic formula here, what will be the quadratic formula? What is the variable here? Cos of theta. So cos of theta is equals to minus times b value. B value is this 1. So minus 1 plus minus b square. B here is 1 minus 4ac. A is 2 and c is minus 1 divided by 2 times a. A here is 2. So after simplification, we will get here cos of theta equals to minus 1 plus minus 3 over 4. Now cos of theta can be minus 1 plus 3 over 4 and cos of theta can be minus 1 minus 3 over 4. Out of here cos of theta will be, from here we can get 1 by 2 and here cos of theta will be minus 1. Now for that cos of theta is equals to 1 by 2, the theta will be pi by 3 and 5 pi by 3. And for cos of theta minus 1, theta will be equals to pi only. Now we have to do what? We know that it is for horizontal tangent, dx by d theta cannot be equals to 0. This means that we know that what is our dx by d theta? Our dx by d theta is sine minus sine of theta minus 2 sine of theta cos of theta. We know that dx by d theta is equals to 0 for theta is equals to pi. If we put theta is equals to pi here, this whole term will become 0. And this whole term will be non-zero for theta is equals to pi by 3 and 5 pi by 3. Now we need to do what? You just have to pick your pi by 3 and 5 pi by 3. So you see here the d horizontal tangent dy by d theta will be 0 for this angle and dx by d theta is not equals to 0 for this angle. So it is fulfilling this property of this for horizontal tangent. So pick this theta, that is theta is equals to pi by 3 and 5 pi by 3 and pick your this r is equals to 1 plus cos of theta. First of all put pi by 3 in this r is equals to 1 plus cos of theta. For theta is equals to pi by 3, my r value will be 1 plus cos pi by 3, that will be equals to 3 by 2. And for theta is equals to 5 pi by 3, r will be equals to 1 plus cos 5 pi by 3, that will be equals to 3 by 2. So it means we have the horizontal tangent at 3 by 2 pi by 3 and 3 by 2 5 pi by 3. Now we have to find down the tangents at the vertical point, so we have to follow the same method. For vertical tangents, dx by d theta is equals to 0, but dy by d theta cannot be equals to 0. Now you have to do what? You have to take the value of dx by d theta. Dx by d theta, make it equals to 0. It will be equals to minus sine of theta minus 2 sine of theta cos of theta is equals to 0. Now take the negative sine of theta common. Inside we will be left with 1 plus 2 cos of theta is equals to 0. It could be sine of theta is equals to 0 and it could be 1 plus 2 cos of theta is equals to 0. Out of here we'll get theta is equals to 0 or pi. We know that sine theta will be 0 at 0 and pi, and out of here we can get cos of theta is equals to minus 1 by 2. So theta will be 2 pi by 3 and 4 pi by 3. And we know that dy by d theta cannot be equals to 0 at theta is equals to 0. 2 pi by 3, this point, and 4 pi by 3. If you put these angles in dy by d theta value, you will get that it will not be equals to 0 at these angles. So you have to consider these angles and use your r is equals to 1 plus cos of theta, put in it and get the values of r. At theta is equals to 0, we will get the value of r is equals to 2. And at theta is equals to 2 pi by 3, we will get the r value as 1 by 2. And at theta is equals to 4 pi by 3, we will get the r value is 1 by 2. So we have the vertical tangents at these 3 points. So in following just this method, you can solve the rest of the questions regarding the horizontal and the vertical tangents. Now we need on to the next question, that is question number 9. In question number 9, we have to find out the equations of tangent and normal to the given curve. X is equals to 2a cos of theta minus a cos of 2 theta and y equals 2a sine of theta minus a sine of 2 theta at theta is equals to pi by 2. Now first of all, you need to find out, basically for finding the equation of tangent and normal, we need the value of slope. We need it. For that purpose, you know that dy by dx equals to dy by d theta into d theta by dx. Or you can also write it like dy by d theta over dx by d theta. It's up to you. You can just find down these values, put in it and get the value of dy by dx. So for that purpose, we need dy by d theta and dx by d theta. So from the first one, dx by d theta, find the derivative of this x with respect to theta. We will get here minus 2a sine of theta plus 2a sine of 2 theta. And out of this, the d theta by dx, we know that we need its reciprocal. It will be equals to 1 over minus 2a sine of theta plus 2a sine of 2 theta. Now we need dy by d theta, so differentiate this one with respect to theta. We will get dy by d theta is equals to 2a cos of theta minus 2a cos of 2 theta. Now my dy by dx will be equals to 2a. Put the values here. We will get here 2a cos of theta minus 2a cos 2 theta divided by 2a sine 2 theta minus 2a sine of theta. Now I can take this 2a common. After taking the common, it will be cancelled out. So I will be left with here only dy by dx is equals to cos of theta minus cos 2 theta divided by sine 2 theta minus sine of theta here. Now you have to convert it into the half angle identities. After converting it into the half angle identities, I will get here how you can convert it. You know that you know the formula for cos of p minus cos of q. Use this formula in the product way. change this subtraction into the product form using these formulas. Here on the numerator you have cos of p minus cos of q form. It will be minus 2 sine p plus q over 2 sine p minus q over 2. This is from the first year book, page number 334. You are given with these formulas. Only 3 are given here. The other one is here, sine p plus sine q form, and here sine p minus sine q, then sine p plus cos of q, cos p minus cos of q. Using these formulas, I am converting it. It will be converted into dy by dx equals 2 sine theta by 2 sine 3 theta by 2 divided by 2 sine of theta by 2 cos of 3 theta by 2. Now this will be cancelled. So dy by dx will be left behind only tangent 3 theta by 2. Now this is our slope. For finding the equation of tangent and equation of slope, equation of normal, we need to find out the slope at the given point. The given point is at theta is equals to pi by 2. So dy by dx at theta is equals to pi by 2 will be equals to tangent 3 by 2, and theta is pi by 2 here. After solving, I will get here minus 1 because it is tangent 3 pi by 4. Now you got the value of slope, tangent, you got the slope, that is tangent at point theta is equals to pi by 2. Yeah, now you need a point using this theta is equals to pi by 2 for x value and for the y value. Now your x is this and y is this. Put the value of this theta is equals to pi by 2 in x and y. You will get a point use the value of theta is equals to pi by 2 in this equation. We will get x1 and y1, that is equals to a 2a. So now equation of tangent at a 2a will be, you know that what is equation of tangent? Y minus y1 is equals to dy by dx at theta is equals to pi by 2 into x minus x1. So it will be y minus, this is y1, 2a equals to, what is the slope here you got? That is minus 1, x minus a. After rearranging, we will get here x plus y is equals to 3a. So this is basically the equation of tangent. Now for equation of normal, we need the slope at normal, and that will be slope of normal at theta is equals to pi by 2 will be 1 minus 1 divided by this slope, minus 1 divided by this slope dy by dx, that is equals to at theta is equals to pi by 2, that is equals to minus 1 divided by minus 1, so it will be equals to 1 only. So now equation of slope will be, equation of normal will be at a 2a, the same point, it will be y minus y1 is equals to the slope of normal. Slope of normal is 1 here into x minus x1. That will be equals to y minus 2a equals 1 minus into 1 into x minus a. After rearranging, you will get here x minus y plus a is equals to 0. So this is the equation of normal here. In this way, you can solve the question number 10 and question number 11 as well. Now move on to question number 12. In question number 12, show that the normal at any point of the curve is at a constant distance from the origin. So for that purpose, you need to find out the equation of normal. X equals a cos of theta plus a theta sine of theta. Y equals a sine of theta minus a theta cos of theta. First of all, we need the slope because we need the equation of normal. In equation of normal, we have to put the slope. For slope, we need dy by dx, and you know that dy by dx is equals to dx by d theta into, you can write it dy by d theta into d theta by dx. So first of all, we need d, from here dy by d theta and d theta by dx. So first of all, from this equation, we can find the value of dx by d theta, that is equals to minus a sine of theta plus a sine of theta plus a theta cos of theta. This is equals to a theta cos of theta. Now dy by d theta will be, differentiate this with respect to theta, we will get here a cos of theta minus a cos of theta plus a theta sine of theta. So it will be a theta sine of theta. So from here, dy by dx, using the values in it, we will get dy by dx is equals to a theta sine of theta divided by a theta cos of theta. That is equals to sine of theta over cos of theta. This one. Now, this is basically the slope of tangent. Slope of normal will be minus 1 over dy by dx. So it will be equals to, put the value here, slope of normal will be minus cos of theta over sine of theta. So equation of normal is, since here there is not given any specific point, so there is no need to find the slope at the specific point and no need to find the specific point here. Just use these points x and y. Equation of normal will be y minus y1 is equals to this slope, that is minus cos of theta over sine of theta times x minus x1. Now y1 and x1 will be the same points because we are not given any specific point that we can use here and get the value of x1, y1. So use these points here directly. We will get here in place of x1 and y1, use the values of this x and y. After putting these values, we will get here now multiply this sine of theta on this side, we will get here and multiply this inside, we will get now after rearranging the terms, after rearranging and simplification, we will get here now we have to prove that the given parametric equations is at a constant distance from the origin. Now this is the equation of normal. We have to prove that this has a constant distance from the origin. So origin has the point 0, 0. It is equals to, now mod, what we have to do, write this in place of x, put the value of this x, and in place of y, put the value of this y. We'll get 0 times cos of theta plus 0 times sine of theta minus a divided by these coefficients square under root. So from here we will get cos square of theta plus sine square of theta will give you 1. So it will be equals to a here, which is constant. So it means the given curve has the normal at a constant distance from the origin. Now question number 14. In question number 14, we have to show that the pedal equations of the asteroid, this asteroid is r square equals a square minus 3p square. The parametric equations given are and we have to show that r square is equals to a square minus 3p square. We have to show this one. First of all, you have to do what? You have to find down the slope because you have to find down the equation of tangent in it. For finding the equation of tangent in it, you need the slope of tangent. And for that purpose, you need dy by dx. That is equals to dy by d theta into d theta by dx. So from this x, we need dx by d theta. That will be equals to minus 3a cos square of theta sine of theta. And from y, we can find the value of dy by d theta, that is equals to 3a sine square of theta cos of theta. Now using these values in this one, we will get the dy by dx. dy by dx will be equals to 3a sine square of theta cos of theta divided by minus 3a cos square of theta sine of theta. That is equals to minus time sine of theta over cos of theta. Now this is the slope of tangent. Now equation of tangent will be y minus y1 is equals to this slope of tangent times x minus x1. Now y1 and x1 are these parametric equations. This one, put the values here. It will be now you have to do what? Multiply this numerator inside and multiply this denominator here on the left side. And after simplification, we will get here now the perpendicular distance from the origin, like we have done this in the previous question, the perpendicular distance from the origin will be mod, in place of x, put the origin point, that is 0, 0. It will be 0 sine of theta plus 0 cos of theta minus this point constant term divided by under root the square of these coefficients x and y. We will get here P equals divided by this one, that is equals to P square. If I take the square on both sides, I will get P square is equals to a square sine square of theta cos square of theta. Now mark it as equation number 1. Now we know that r square is equals to x square plus y square. So if I put the value of x and y in this place, I will get r square is equals to a square cos 6 of theta plus a square sine 6 of theta. Now factorize it, we'll get r square is equals to, take a square common, we'll get cos 6 of theta plus sine 6 of theta here. Now here we can use the formula of cube. We can use formula a cube plus b cube, that is equals to a plus b into a square minus ab plus b square. Now what is our here? A here is cos square of theta and b here is sine square of theta. This is a and this is b. Put the values here and after using this formula, we will get here r square is equals to a square times cos square of theta plus sine square of theta into cos 4 of theta minus sine square of theta cos square of theta and plus sine 4 of theta. This term will goes to 1. So we will be left with r square is equals to only a square times this term, that is cos 4 of theta minus sine square of theta cos square of theta plus sine 4 of theta. Now we can complete its square by completing square method. After using the completing square method, I will get here a square times cos square of theta plus sine square of theta whole square minus 3 sine square of theta cos square of theta. Now this term goes to 1. So I will be left with r square is equals to a square times 1 minus 3 sine square of theta cos square of theta here. Now it can be written as r square is equals to a square minus 3a square sine square of theta cos square of theta. So it will become r square minus a square is equals to minus 3a square sine square of theta cos square of theta. And we know that from equation number 1, a square sine square of theta cos square of theta is equals to p square. So a square sine square of theta cos square theta will be replaced with p square from equation number 1. So it will be r square minus a square is equals to minus 3p square. Now what we have to prove? We have to prove in this question that r square is equals to a square minus 3p square. So move this a square on the right side. I will be left with r square is equals to a square minus 3p square. And that is the thing that we were struggling to prove in this question. Now come on question number 15. It is with the same method. Prove that the pedal equations of the curve, this curve is 9 times r square minus a square is equals to 8p square. So the curve is x is equals to 2a cos of theta minus a cos 2 theta and y is equals to 2a sine of theta minus a sine 2 theta. And what we have to prove? 9 times r square minus a square is equals to 8p square. First of all, we need to do what? We have to find out the equation of tangent. For that purpose, we need the value of slope. So, first of all, we need the value of dx by d theta. That is after finding the derivative, we will get minus 2a sine of theta plus 2a sine of 2 theta. After simplification, we get here 4a sine theta by 2 cos 3 theta by 2. I have used here that formula that I have showed you from the first year book. The subtraction or addition into the product conversion. You have to use that conversion here. Then from this y, we will find dy by d theta, that is equals to 2a cos of theta minus 2a cos 2 theta, that will be equals to 4a sine of theta by 2 sine of 3 theta by 2. Now we need the slope, that is dy by dx, that is equals to what? Dy by d theta into d theta by dx. Using the values here, I will get here sine 3 theta by 2 divided by cos 3 theta by 2. And after division, I will get here tangent 3 theta by 2. You can convert it tangent 3 theta by 2 or just leave it as it is. Now equation of tangent will be y minus y1 is equals to slope times x minus x1. Now x1 and y1 are the given these points. Put in it and simplify it. I will get here, after putting, I will get here y minus 2a sine of theta plus a sine 2 theta is equals to sine 3 theta by 2 over cos 3 theta by 2 into x minus 2a cos of theta plus a cos of 2 theta. Now multiply this inside and multiply denominator here on the left side, and after simplification I will get here y cos 3 theta by 2 minus 2a sine of theta cos of 3 theta by 2 plus a sine of 2 theta cos of 3 theta by 2. After multiplication I am writing the answer. X sine 3 theta by 2 minus 2a cos of theta sine of 3 theta by 2 plus a cos of 2 theta sine of 3 theta by 2. Now what I can do, just move everything on the left side and take the terms that are common. After simplification, I will get here x sine of 3 theta by 2. Move your all right hand side on the left hand side. Take the common terms and I will get here x sine 3 theta by 2 minus y cos 3 theta by 2 minus 2a sine of theta by 2 minus a sine of theta by 2 is equals to 0. Now these terms can be simplified. I will get x sine 3 theta by 2 minus y cos 3 theta by 2 minus 3a sine theta by 2 is equals to 0. Now the perpendicular distance will be, perpendicular distance from the origin will be, put in place of x and y 0. I will get here 0 times sine 3 theta by 2, that is 0. Again 0 here, and only I will be left with minus 3a sine theta by 2 divided by this square and this square. So it will be equals to p is equals to only 3a sine theta by 2, because this term will give you 1. Now take the square on both sides. P square will be 9a square sine square theta by 2. Now we need what? R square is equals to x square plus y square. Keep it in your mind. Mark it as equation number 1. Now consider R square is equals to x square plus y square. Put the value of x and y from the question in it. I will get here R square is equals to, after putting the value of x and y from the question here, and after simplification I will get here 5a square minus 4a square cos of theta. Now if you observe, it is in sine square theta by 2. I can convert this cos of theta in sine square of theta by 2. How? R square is equals to 5a square minus 4a square. Now this cos of theta, break it into the half angle identity, and I will get here 1 minus 2 sine square theta by 2. Open it. I will get here R square is equals to, after simplification, a square plus 8a square sine square of theta by 2. So it will be R square minus a square is equals to 8a square sine square of theta by 2. So now from here I need the value of a square sine square theta by 2 from equation number 1. A square sine square of theta by 2 will be p square by 9. So it will be r square minus a square is equals to 8 p square over 9. So it will become 9 times r square minus a square is equals to 8p square. And this is the same thing that we need to prove in this question.